Alright, in this video we're going to look at solving some linear inequalities. Well, not necessarily linear inequalities, just inequalities in two dimensions. So here we're going to look at y is less than negative 2x plus 7. So this is going to be a line with a y-intercept of 0 and 7. So that's where we're going to start. And our slope is going to be negative 2 over 1, which says we're going to go down 2 and to the right 1 from 7. So we're going to go ahead and do that. And because it's a strict inequality y less than, we're going to have a dashed line there. So we're going to plot in some points, just going down to right 1, dashed line, and then what we're going to do is we're going to shade either below the line or above the line. And the easiest point to test, as long as your graph doesn't go through the origin, is just to test the origin. If it's true here with the origin, that means we're going to shade where the origin is. If it's false when we plug in the origin, we're going to shade on the other side, so we would shade up above. Okay. So we're going to go ahead and we're going to test 0, 0 because that's the easiest point to test. So then we'll have 0 is less than negative 2 times 0 plus 7, and 0 is less than 7. That's true. So that tells us we're going to shade on the side where 0 is. And because it gets pretty messy, I'm just going to draw some arrows just to point that we're going to shade below. And what we're going to do is we're going to actually do the shading where we have overlap. So we're going to look at the other part of the inequality is y is greater than or equal to negative x plus 3. That has a y-intercept of 0 and 3, and then a slope of negative 1 over 1. So we'll start at 0, 3, and we're going to go down 1 and to the right 1. And I'm just going to plot a bunch of points there just to kind of help myself out. So earlier we solved the system and we found that that was the actual solution where the two graphs intersected. This is an inequality, so we're going to be looking at where the shaded region overlaps here. Okay, this is allows to be equal to, so the greater than or equal to. So that tells us that we'll use a solid line. And then again, I'm just going to test 0, 0 because that's the easiest one to test. And if it's false, I'm going to shade above because 0, 0 is below. And if it's true, I'm going to shade below because that's where the origin is, the 0, 0. So 0, when we plug in 0, 0 is not greater than or equal to 3, so that's false. So we're going to shade above. I'm just going to draw myself some arrows just to kind of help myself out. And I see that I have the intersection right here. And that's what I went ahead and highlighted. So that's my actual solution to this system of inequalities. Okay, we're going to look at two more examples. These are the same ones that are in your notes, and they are filled out in your notes, but it might be helpful just to watch a video on it also. Okay, so let's do another one. So we're going to have x squared plus y squared less than 9, and what that's going to be is that's going to be a circle. If you just have x squared plus y squared equals a number, it's going to be a circle centered at 0 at the origin with a radius, the square root of what it's equal to. So it's equal to 9, so the square root of 9 is 3. So we're going to have a circle centered at the origin with a radius of 3. So we're going to go ahead and draw that in. Because it's a strict inequality, I'll go ahead and fix that in a moment, but it should be a dashed circle, not a solid circle like I have drawn in right now. Okay, now we're going to test the origin, 0, 0. So 0, 0 is inside the circle. So with a circle, I'm either going to shade inside or outside. If it's true, that's where 0, 0 is. We're going to shade inside, and in fact, it is true. So we're going to shade inside the circle. So I'm just going to draw some arrows to kind of indicate that, and then I'm going to go ahead and make this a dashed circle here. All right. I'm going to take a look at another inequality. We're going to have y is greater than or equal to x squared minus 9. So you know how to graph that, just a parabola. Down 9 units, and then plot some points. You know how to plot some points. There's our parabola. Notice it crosses at -3 and 3. Those are the x-intercepts of the parabola. Now we're going to test 0, 0. 0 is inside the parabola. So we're either going to shade inside the parabola if it's true for 0, 0, or we're going to shade outside the parabola if it's false. Okay. So we'll test 0, 0 and we'll see if it's true or false. So 0 greater than or equal to 0 squared minus 9. Well, that's true. So that tells us we're going to shade inside the parabola. So where we're going to shade is inside the parabola and inside the circle, because we've got to make everybody happy. And that is the set of all points that make both the red inequality and the blue inequality true. Anything that's in that circle there satisfies both inequalities. Okay, we'll do one more. Okay, so this time we're going to do, and this gets into, if you're planning on taking finite math, it's called linear programming, and you're looking for the acceptable region here, and you may have some sort of maximizing or minimizing equation based on your constraints, and that's what we're going to take a look at here. So x is greater than 0. That just means we're going to be in quadrants 1 and 4. So that's where x is positive, or 0. Our next constraint is y is greater than or equal to 0. So that means we're in quadrants 2 or 1. So I'm just drawing those arrows in. So now we're really only living in quadrant 1, because that's where both the x and the y are positive. And we're going to be given a couple more constraints. X is less than 6, so we're going to go all the way out to 6. It's going to be a vertical line. Okay. Less than 6 would be to the left. Okay, so now we're in a rectangular region inside quadrant 1 right here. Now we'll have y is less than or equal to 8, so it's going to be a horizontal line. It's going to be a solid line at height 8. Because it's less than, we're going to be below that red line. So now we're just looking at this region right here. And the last thing we're going to do is we're going to look at the line y is greater than or equal to 3x minus 1. Has a y-intercept of -1 and a slope of up 3, right 1. Okay, and there it is. So we're going to be looking at this trapezoid region, or this. This is also going to be a trapezoid region. It looks pretty close to a triangle, though. So we're going to go ahead and test the origin. So we'll either shade to the left or the right. If it's true, we'll shade to the left. So 0 is greater than 3 times 0 minus 1. That's true. So we're going to shade to the left of the blue line. Okay, so we're looking at that almost triangular region there, and that's going to be our acceptable region. If you do plan on taking finite math, then the other thing that you'll end up looking at are the vertices of this region. So there's one there, one there, one there, and one there. And then you'd have some sort of formula for profit or cost or something like that, or maybe some other sort of applications. And you'd use those vertices, and that would tell you one of them would be the max and the min for some sort of formula there in finite math. Anyways, so that's linear inequalities.